Antimatter. I came across this fascinating concept a few years ago when I was reading one of my all-time favorite books, Angels and Demons by Dan Brown. And I remember being so astounded, so stunned by this reality that it sparked an undying interest for the broader spectrum of the universe and its physics in me. Now, I know that I'm definitely not a professional or an expert of any kind whatsoever when it comes to this topic or modern physics in general, since I'm just another high school student, but I'm sure that this will ignite an interest in everyone's minds like it did for me. Now, the very first page of Angels and Demons states that antimatter is the most powerful energy source on this planet. It releases energy with 100% efficiency, while nuclear fission is only 1.5% efficient. Antimatter creates no pollution or no radiation, and a single droplet of it could power New York City for a full day. There is, however, one catch. Antimatter is extremely unstable. It ignites when it comes in contact with absolutely anything, even air. A single gram of antimatter contains the energy of a 200 kiloton nuclear bomb, the size of the bomb dropped in Hiroshima. So all of that was just me reciting 2 paragraphs of the book, which got me hooked to read all 620 pages of it. So I'm going to stop rambling about the book and move on to the topic that the book centered around, which is antimatter. So what is antimatter? Well, to be brief, it's the opposite of matter. To elaborate, when the Big Bang formed, it should have created equal parts of matter and antimatter. However, it's not exactly tangible to us. We don't see antimatter as frequently as we see matter, which brings up the question, where is all this antimatter? One possible yet extremely obvious answer is the fact that currently there's a difference in the ratio of the amounts of matter and antimatter, which left behind a rather big surplus of matter. A second possible answer is the fact that the annihilation of this matter and antimatter was incomplete, and that this matter and antimatter sort of escaped from each other. This can mean that somewhere out there, deep in the very depths of the universe, antimatter is there, waiting and lurking in the forms of anti-stars and anti-galaxies. Thing is, even if we saw a piece of material, we wouldn't be able to tell if this lump was matter or antimatter. That's right, both antimatter and matter look the exact same to the naked eye. However, thankfully, if one takes a peek into the very compositions of the atoms, the true difference is visible. Antimatter is composed of something called antiparticles. And every particle has an antimatter companion, which is essentially identical to each other in almost every single way, including mass, except charge. An antiparticle has the opposite charge of the particle given. To make this a little bit clearer, I'll display a very basic element, which is hydrogen. As you can see, there's a proton in the nucleus, and there's an electron in the outer shell. And for antihydrogen, there's an antiproton, and there's a positron floating around in the shell instead of an electron. When these two sides of the same coin meet, they destroy each other. There's an immense annihilation that takes place. This is what makes antimatter so dangerous. So here's a shocking bit. 1 gram of antimatter costs 62.5 trillion US dollars. And the reason behind why it's so expensive is quite obvious. We do not have a lot in our possession, and the possibilities that it holds is absolutely mind-blowing. A single gram of antimatter is more than enough to power a spacecraft all the way to Mars or create a bomb equal to the one dropped in Hiroshima. How about we look at the less revolutionary aspects of antimatter? I'm sure some, if not most of you, have heard of PET scans. The P in PET stands for positron, and the process of PET scans involves injecting positrons into the brain and watching for gamma rays that flash when these positrons encounter electrons of normal matter. It has been said that antimatter can be used not only to identify cancer, but to cure it as well, similar to a process called ion therapy, which uses a beam of protons to irradiate and destroy a tumor without affecting any of the surrounding tissue. If we use antiprotons instead of these protons, the energy that the annihilation gives off is deposited around the tumor, essentially giving this tumor 2 blasts instead of 1. However, despite all of these captivating possibilities, we do not have a lot of antimatter with us right now. All of the antiprotons created with Fermilab's Tevatron particle accelerator only add up to 15 nanograms. Those made at CERN add up to 1 nanogram, and all of the and all of the protons created at DSY in Germany adds up to 2 nanograms. To give a clear picture of how little antimatter we have with us right now, if all of the antimatter ever produced by human beings was to be annihilated at once, the energy that this reaction produces would not even be enough to boil a simple cup of tea. Antimatter is possibly the most expensive substance to produce. It costs 25 billion US dollars just to produce a single gram of antimatter. And also, due to current technology, we can only produce up to 10 nanograms per year. The question comes with the efficiency and the desperation from our antimatter. As seen, this process is not nearly efficient, and it definitely is a huge drain of wealth and resources if scientists decide to keep pursuing it, which they are. All kinds of research is being done with antimatter, including its behavior in gravity and ways of transporting it. So one might ask the question of whether we really need all this antimatter. Is it really worth the billions of dollars and the tremendous amounts of effort and research that goes into this? Also, what if the planet actually explodes due to any mishap? I'm going to answer my own questions here by diving into a little bit of numbers. So a matter-antimatter reaction is 100% efficient. However, due to today's technology, we can only acquire up to 50% efficiency, which is still amazing because even nuclear fission is not as efficient as this reaction. So if we ever have 1 kilogram of antimatter and we react this with 1 kilogram of matter, the energy that this reaction produces is equal to the energy that 47 megatons of TNT produces, which is equal to about 200 quadrillion joules, which is a number 2 followed by 17 zeros. Keep in mind that the annual demand for energy is about 530,000 joules, but this is expected to rise to 800,000 joules soon. So if we go at this rate, we can power planet Earth for 250 billion years with this simple reaction. Also, past inventions and discoveries have made it quite obvious that at some point in the future, antimatter wouldn't cost a fraction of what it costs today and would be much easier to work with and handle. An example is computers, which were once extremely costly and accessible only to the wealthiest members of the society. Take into example HP 3000, the basic model of HP 3000, which costed about 95,000 US dollars in 1972, which in today's value is approximately slightly over $500,000. This will most likely be the case with antimatter as well. It might seem extremely illogical and impractical to go behind it, chase it until we derive its maximum potential. However, if past inventors had the same mentality about computers, then we wouldn't have the privilege of knowledge and information at our fingertips like we do today. Also, when I was reading Angels and Demons, the possible question of a planet explosion kept daunting me. As I said before, if all of the antimatter ever produced by human beings was to be gathered at once, the energy that this reaction produces is not even enough to boil a simple cup of tea. And looking at short-term goals, scientists are not interested in creating enough antimatter to produce an actual world-destroying bomb. Also, particle physicist Frank Close pointed out an issue with these horrible bombs. He said that it would take us 10 billion years to create a bomb the size that Dan Brown keeps talking about in his book. So with all these reassurances, let's just hope for the beneficial side of antimatter instead of wondering about world destruction. Evidently, antimatter could be our portal to a whole new world, literally. It has the capacity to provide us with revolutionary scientific achievements, like interstellar travel, advanced medical aid that would make once deadly diseases like cancer absolutely extinct, and also the massive amounts of extremely efficient energy that could potentially reduce our dependence on other forms of inefficient and unclean energy sources. Looking at all of these possibilities, one can only be so enchanted by antimatter, and we should surely hope for and work towards the further achievement of antimatter, and finally make the stuff which was once fictional into a legitimate reality that we can finally depend on. Let's hope that science and technology will continue to marvel us once again and would fascinate our future generations as well. With that, I hope that you finally comprehend the magic of this phenomenal substance and the actual matter with antimatter.